Question number 7 asks us to draw the inverse function of f of x equals root x plus 2. So that black graph is square root x plus 2. It has a vertex at negative 2, 0. And on the left-hand side table, I've written in the coordinates I've highlighted in yellow. Now, inverse means that we are switching x and y. So what I will do is take all those x coordinates, and then I'm going to move them over to the y column. So negative 2, negative 1, 2, and 7. And all the y coordinates, we're going to move over to the x coordinates. So 0, 1, 2, and 3. And when we do draw these new points, so 0, negative 2, if we compare it to the original point at negative 2, 0, it is a mirror image of that coordinate across that diagonal line, y equals x. Okay, and I'm just going to write it in here, y equals x, because that represents a line of reflection. At 1, negative 1, that's a reflection of that point. At 2, 2, that happens to be an invariant point because that's going to be right on the mirror line. And at 3, 7, okay, I'm going to end up with a point there. And this, when I sketch this graph in, we have a mirror image of, we've got a mirror image of that black line. So I'll just sketch it in again. Okay, so that red line represents a mirror image of that black line. And notice that the domain here is x is greater than or equal to negative 2. The range of this function is going to be y is greater than or equal to negative 2 because the domain and range will switch there. Same with the range. Range is y is greater than or equal to 0. Notice that because we only have half the parabola, the domain of this new function is going to be x is greater than or equal to 0. Now, if we actually solve for y in this case, we're going to end up with a quadratic function, and if we're not careful, you will use the domain as all real numbers on that quadratic function, but it's not a full parabola. It's only a half parabola. For number 8, it says, what's the domain and range of the function? Well, the domain is going to be based on some restrictions, and those restrictions are going to be based on the inside square root. Okay, so that inside square root, we know that the boundary is going to be 0, so solving this 2x minus 5 equals 0, I get my boundary is equal to 5 over 2 or 2.5. So we know that the boundary is going to be 5 over 2. And because this is a graph that opens to the right, we know that the x values of that domain should be greater than or equal to that. And we can check it. We can test some numbers like 5. If I plug 5 in, that I can square root 5. If I plug in 0, I'm going to end up with a negative inside the square root, which won't work. As for the range, it's anything on the outside. So normally, our range for the square root function is going to be bigger than 0, but in this case we have a vertical shift, so y is going to be greater than or equal to positive 2. For number 9, it says we have the parabola f of x, so in green we have the parabola, and we want to estimate what the graph looks like when we do a square root transformation. Okay, so what's happening with square root transformations? Well, when we have the f of x inside the square root, we can no longer have negative f of x values. So what will happen then is these coordinates here that are below the x-axis, we have to get rid of those coordinates. Okay, let's just do that in blue. So these coordinates that are negative, okay, they're going to be way down here and way down here. These coordinates, we need to get rid of those because they cannot be square rooted, so they cannot exist in the new function. What will happen then is we have our boundary points. Our boundary points are going to be the 0 points, so y equals 0 and y equals 0, and that's going to be for 6 and 0. So the y values of 0, when we square root them, they remain 0. The other coordinate is going to be the vertex. So we started off at 3 and y equals 9. Well, we square root that 9, we're going to get the new y coordinate of 3. So I'm going to draw that point in there. These points are important. These are boundary points, or they're zeros. Those are the boundaries for square root. And then we have our vertex. Since we have the value of the vertex in the green as equal to positive 9, we can actually square root that y value and get the value of the vertex as y equals 3 on that black graph. The domain of this function then ends up being from 0 to 6. And we can write it in interval notation from 0 to 6. And the range of this function is from 0 to the vertex, which is at 3.